We left off in our last class with a discussion of equations. We saw numerical equations that were true, others that were false, and other equations that contained one or more variables that we called open. Here are a few more examples just to see what you remember from last class, and we'll review those during our session today. I want to go back to translations. We translated when we had expressions back in the last chapter, and now we're going to add one key component to that. We're going to translate equations. We're going to see words like is equal to or equals or the word is. The word is will also tell you that you want to write an equation. Okay, so let's take a look at these. And once we translate them, we're going to decide if they are true, false, or open. 1/2 of a number n, 1/2 of a number n, that's 1/2 times n, is equal to 7. As soon as I saw that number and I used the variable n, I know that this is an open sentence. On to our next one. The product of 12 and -4 tells me I'm multiplying. The product of 12 and -4 is -48. If I simplify the left, I see that this is a true sentence. 54 divided by 6 equals 8. Well, if I do the math on the left and I calculate, I get 9, which does not equal 8. This is a false sentence. Final one. 7 less than the product of x and 3, 7 less than the product of x and 3 is equal to 4. Well, as soon as I saw a variable there, I knew this was an open sentence or open equation. So there we have our translations. We then talked about possible solutions where we substitute in a given value to see if it makes this sentence true. Will the two sides balance? Will they name the same number? We're going to take x out and replace it with 5. We're going to do the math using our order of operations. And I see that 18 equals 18, so I will say that 5 is a solution to this equation. Next one. This time we're going to replace x with -2. -2 minus 6 equals 4. Sometimes when we're solving an equation, we may have a wrong sign or we may do the wrong operation, so it's always good to check. Well, we're practicing our rules here because subtraction says to add the opposite. And this will give me -8 is equal to 4, which is false, so we can draw the conclusion that -2 is not a solution. On to the third. Is 2 a solution to this equation? Well, let's put that 2 in there. And as we simplify, it comes out to 10, and 10 does not equal to 6. So again, this case, 2 is not a solution. So this is what you do when you solve an equation. I ask you to do the check. So now we've actually done the check before we've done any solving. So let's talk about solving. We'll start by adding or subtracting. When you solve an equation, the whole goal is to get the variable by itself on one side of the equation so we can see what value makes this true. We're going to use inverse operations which undo each other to get the variable alone. We'll start with addition and subtraction, and we'll talk about how they are inverse operations and they undo each other. The same is true with multiplication and division. They are also inverse operations. Now there's something called the subtraction property of equality. And it says you can subtract the same number from each side of an equation and it'll still be equal. So if I start off with x plus 6 equals 4, I'm going to go ahead and subtract 6 on both sides. That is my subtraction property of equality. It's also my inverse operation. So when I take a number and I add or subtract its opposite, it cancels out. I'm isolating x. And then remember that when I'm subtracting, I have to add the opposite. So I get x is equal to -2. Or at least that's what I think my answer is. So I am going to substitute it back in. This is called the check. This is what we did on the previous examples where we took a value, -2, replaced x with that -2 into the original equation, and we look to see if it makes a true statement. Well, when my signs are unlike, I subtract to keep the sign of the greater absolute value, and the two sides are equal, so that I was correct. -2 is a solution. Now that was the subtraction property of equality. We also have the addition property of equality, where we can add the same number to each side of an equation when we start off with a subtraction. So again, we look at the original equation. This is a subtraction equation, so I'm going to do the inverse. I will add 10. But my addition property of equality says if I add 10 on one side, I must add 10 on the other. It will cancel out here, leaving me with x. I now have unlike signs, so I'll subtract and keep the sign of my greater absolute value. I have to double check because I can never be sure that I'm 100% right unless I do the check. I'm going to take that -14 and subtract 10, and I'm wondering if, this is kind of a question mark here, I'm wondering if it equals -24. Well, if I remember, my rules of subtraction tell me to add the opposite. And if I go ahead and see that the signs are the same and I add and keep the sign, I get -24 equals -24, and it checks. Let's try one or two more. Again, now I've been writing it horizontally. Many people will just write it below, and this works as well if this is what you're used to. It will cancel out on the left, and I add on the right. I could do the check, and I'd say 25 minus 7, does that equal 18? Don't assume that you have it right. Actually do the calculation, and we see that it works. Let's just do another, and again, I see subtraction, so I think let's add inverse, opposite operation, and this is using the addition property of equality. If I add 9 to one side and I add 9 to the other side, it keeps the balance. Well, if I take 9 from 15, it does give me 6, so it checks. Okay, this is an addition equation. It goes back to the subtraction property of equality. So I'll subtract 4 on both sides. When I subtract 4 on both sides, remember subtraction tells me to add the opposite. So it cancels, and that gives me -2. But what if I made a mistake? Let me check. -2 plus 4. Because a mistake can happen to anyone, I'm going to see my signs are unlike. I will subtract and keep the sign of my greater absolute value, and it works. Now, of course, I'm keeping my numbers low right now, but when the numbers are higher, especially when we're dealing with signed numbers, it's always good to do the check. So you'll be doing some problems tonight, and we'll check them next class.